gradient of a velocity time graph is the acceleration. So, if we're thinking about that here, we should be drawing something here with a gradient equal to 10. How do we know if the gradient is equal to 10? Well, let's use our v equal to u plus at. U is 0. After 0.1 seconds, 0.1 times 10 gives me 1. 0.2 times 10, sorry, is going to give me 2, and 3 meters per second at each of those points. Okay, so we've got a mark here of the 2 for a straight line, and the other one for it being a straight line with gradient 10. Okay, let's come through. Now this is, I find this question a really hard one, okay, and we're going to have to do a bit of flicking around the paper to make sure that we can sort of understand the setup here. The net is stretched across the middle of the table. The table has a length of 2.74 meters, and the net has a height of 15 centimeters. So what I've done actually over here is drawn this. Okay, we had a length of 2.74. It's in the middle of the table, and so therefore we're at a distance here of 1.37 meters and a height of 15 centimeters. Okay, now we'll just go back down. What are we being asked? We're being asked to show that the ball will go over the net. So in essence, what you're being asked to consider here is the position both in x and y of the ball when it's here. So when x is equal to 1.37, is the y displacement, is the y position greater or less than 15 centimeters? If it's greater, then it goes over, and if it's less, then it's going to not go over. Well, to do this, we firstly think about the x direction, because we need to think about the time at which we are going to be reaching that net. And the way we do this, we know that the displacement is given to u plus v times t over 2, slightly different to the equation in the book. S here is half the length of the table, 1.37 meters, and u and v are actually the same. They're both 12, because we're assuming here 0 air resistance. In other words, this is projectile motion with constant velocity in the x direction. We can therefore do a bit of maths magic. We get out that the the time at which we reach that net position is going to be 0.114 seconds. Okay, so what that says is that my ball, after it starts its trajectory, is going to be at this position somewhere along this line at a time of 0.114. Now the question is it above or below the surface of the net? Well, we're then going to do our y direction. We're going to use s equals to u is equal to half t squared again, because we know that u is 0 in the y direction. And we're going to just work out the displacement from that starting position. And what you find, once you put in that time, we get a displacement from the starting position of minus 0.06 meters. Now, what does that mean? Well, that means that we started at 0.24, and we've gone down by 0.06. So we're somewhere around right here at y position h of 0.24 minus 0.06, which is 0.18. Now, the result of that is that the ball will go over, because 0.18 is greater than 0.15. Okay, really nice question, this one. Lots to think about, and as I said before, a lot to do with your kind of thinking about what's happening in the x and the y directions. Okay, 1D. The ball bounces and then reaches a peak height of 0.18 meters above the table with a horizontal speed of 10.5 meters per second. Determine the kinetic energy of the ball immediately after the bounce. Please ignore the building works that are going around beside me now. Key point about this one is that when the ball leaves the ground, it actually has a horizontal and a vertical component. It does not only have a horizontal component. So what you're tempted to do here is half mv squared and simply put in that v value of 10.5. Well, actually, we have to think a little bit more about the y direction, because it has a y component. Now, one way we could work out the y component is by simply thinking, well, we want to know the initial velocity in the y direction. We know that it bounces to a height of 0.18, and we know that it's working against gravity. So we're going to use our v squared equals u squared plus 2s in the y direction, so that is y is here. We know that at the top there, its velocity is 0, and therefore its initial velocity is going to become from our 2 times our acceleration minus 10.81 times our displacement in the y direction. So we end up with an initial velocity in the y direction of 1.88 meters per second. We then use energy conservation using gravitational potential energy as well. Okay, key idea here is actually this is a really difficult question, and you get no marks simply for writing half mv squared. You must remember that it has actually two components, the x direction and the y direction, and there is